Hello and welcome to the Computer Vision Festival, hosted by the AI Accelerator Institute, a global community of over 400,000 AI leaders and practitioners, all striving towards one shared goal: inspiring the next generation of machine intelligence. With expert presentations on the festival agenda covering everything from space exploration on Mars to self-supervised learning, you're in for a treat. If you have any questions for our speakers or want to connect with them further, then ask away in the comment sections of the video and hear them answered at the end of each session in our live Q&As. If throughout the day you're loving the content, then be sure to check out the AI membership plans, where you can get access to exclusive content in the form of interviews, reports and articles. Access all areas passes to all past and future events. You can also join our Slack community, which is home to more than 2,500 fellow AI, machine learning and computer vision professionals, and is full of dynamic conversations and contributions. So if you're not already a member, come and join us today. Sign up using the link on the AI Accelerator Institute website. I want to say a massive thank you to all of our sponsors and partners for helping us to bring the festival to your screens today. Our amazing speakers for contributing some awesome content, and to you, our attendees, for joining us today. That's it from us, so go ahead, sit back, relax, and enjoy the festival.
So it looks like we've got some people coming in here. I'm gonna wait just for a moment. But I think we are okay to go in here. So everyone, yep, all right, everyone, let's go. I'm getting the signal, let's go. So thank you guys for joining us today. We've got a really incredible group of panelists here to talk about innovation and industrial innovation. So how are we using machine learning and computer vision in the industrial space specifically? My name is Ray Pop. I'm the CMO of Levatas. Levatas is a company, we're based out of South Florida, who consults on and builds products for automating industrial inspection. My colleague Santiago is on the panel as well. He'll probably get a little more in depth into that. So I'd like to start by we'll start with Christian. We'll do a quick introduction and then we'll go around just so everyone knows who you are, where you work, and what it is that you do. So Christian, we'll start with you.
Sure, yeah. Hi, my name is Christian Georgiev. I work at Material Handling Systems, or for short MHS. We're the largest material handling company in North America, and I think number 4 or number 6 in the world. And traditionally, our business is producing conveyor belt systems, installing them, managing them, and so on. And last 4 years, we started, an R&D division, which I currently lead the computer vision and software part of it. And we have developed a robot simulator basically for finding out packages from a scene and then pulling them one at a time. And we have it deployed at a few locations around the country.
Awesome. Thank you very much. I'm going to go clockwise on my screen here. So Santiago, you would be next.
Yeah, so my name is Santiago Valderrama. I've been working with Levatas, a South Florida company, for the last almost 11 years right now. And I'm currently the Director of Computer Vision Solutions there. And as Ray mentioned, we specialize in computer vision for inspections and anything that's related with manufacturing, etc.
Amazing. Muhammad, and who told me to call him Mo, which is greatly appreciated. You will be next. So Mo, let us know about your situation.
Yeah, thank you, Ray. Hi, everyone. I'm Mo, as Ray said. And I have a background in engineering, PhD in AI. I currently work as the head of AI at Rolls-Royce PLC, leading the AI teams across Europe, working on some really exciting challenges. So Rolls-Royce, we are the power system company, I should say, not the car company. We build everything from airplane jet engines and nuclear reactors. Lots of interesting and exciting application in computer vision. And then lastly, I just want to say you have a fantastic panel here. I'm truly looking forward to this discussion.
Yeah, likewise. Thank you, Mo. Last but not least, Jacob.
Yeah, hi. Thank you for having me. I'm Jacob. I work with Volkswagen, a company you might know, so one of the biggest car producers in the world. I work for the production department in the digitization. So I'm in my role as product owner for industrial computer vision. I'm looking for nice applications of computer vision within the industry context. I'm responsible for implementing this. So probably more on the business customer side in that round here.
Yeah, great. Thank you guys. Really appreciate it. We've got a nice cross section of industries here, and also with Santiago, I can speak to as well. You know, our business crosses a lot of different industries as well, so it'd be neat to connect the dots on some of the common challenges. And I'll start by saying, you know, as the lone marketer here in the room, I feel somewhat guilty for perpetuating this idea of AI and CV solutions being turnkey or out of the box. Particularly in industry, right, and at the enterprise level. So, but I'd like to get a feel for, you know, maybe shed some light on what the real life cycle of operational solutions is right now. What's that delta, right? I mean, you know, people talk about, you know, let's turnkey, let's plug and play, right? Whatever term you want to use, but that's clearly not the case. I want to talk a little bit about the life cycle and, you know, what's the reality? How close are we? You know, from what marketers are talking about to being able to really scale some of these solutions out.
Yeah, I can definitely start with that one. So yeah, there is definitely a gap between the marketing materials, what you read about AI, and what the reality actually is, right? So number one, most companies that we start interacting with, they're not even at a point where they can apply AI solutions because they don't have data, right? So they have a problem, they have a challenge. And when you start digging a little bit deeper, you realize that the data is not there. They're not capturing the right data, or they're not capturing data at all. So that's usually the first thing that we have to think about. So usually in a life cycle of a full solution, everyone hypes the sexy part, which is the machine learning part, right? It's, you know, the modeling part, and this is what we're all gonna be doing. In reality, a life cycle of a system, it needs a lot more than modeling. So it usually starts by the scoping the work, and that is understanding the problem, talking to the subject matter experts, what success looks like. So it's establishing the metrics that are gonna help us solve that problem successfully. That's number one. That's the scoping part of the project. Number two is the data that goes from data acquisition. So where is that data? Does it even exist? How do we capture it? You know, do we need cameras? Do we need sensors? So establishing all of that, all the way to transforming the raw data that we're capturing to data that can actually be fed into a computer vision model or a machine learning model. Then you get to the modeling part, which is, you know, the sexy part where data scientists, you know, engineers get to design that model, get to build those predictions. And then finally, you go to the deployment stage, which is usually deployment, maintenance of that model, and monitoring of that model. And these are usual challenges that people don't talk a lot about, but they are really important. So one thing specific to machine learning solutions is that the minute you deploy your model, that model will start degrading, and depending on where you're or what you're doing, what the subject is, that degradation might happen fast. There are usually two concepts. We call them concept drift and data drift. Like, for example, if you are taking pictures with, you know, every year new cell phones are going to change cameras. So let's say you're, you know, consuming images coming from cameras, that better quality on those images will unfortunately degrade the ability of a model that was trained with all cameras to produce good results. So that's why we constantly need to keep monitoring those models and adapting to that. So that's the sort of like the full life cycle. Mm-hmm. There is a lot of work here, and it's interesting, like you mentioned, that's sort of like part of the gap that when you read a marketing piece is usually, you know, plug and play and get your solution, and the reality is very, very different.
Are you guys finding some of the same? Anyone else have any thoughts on what you're finding in this life cycle, the reality? This is the chance to you know, kind of set expectations properly, right?
Yeah, maybe I can add on this from Volkswagen perspective. We see that a lot, external parties selling interesting, cool use cases that our productions area need. But what we figured out usually was that piloting something was super easy. So machine learning works nicely, and taking a couple of pictures, labeling them, no problem at all. That works within a couple of weeks. But where it's really a tough one is to move from the pilot phase to integrating it sustainably into the production line, because you need maximum reliability here, maximum recall precision and things like that. And that's something that most external companies struggle with, because at least our expectations there are extreme, and that's probably nothing that an external company can easily provide with. That was our major insight. A lot of companies trying it.
Yeah,
interesting. So just to so first of all, I completely agree with what Santiago and Jacob just mentioned. We definitely see similar challenges here at Rolls-Royce, but I also want to touch on the point that across different disciplines, perhaps computer vision is one of those where the relation between academic or startups and the industry is probably the healthiest that I have seen, definitely across, as I said, multiple disciplines. There is a smaller gap between what's happening in research and what is currently being deployed in the industries. An example is CVPR, as we know, is already happening as we speak. And we actually have seen some papers being published that we are already discussing how can we make use of them internally here in Rolls-Royce, as in the gap is smaller. That is one idea. And then the data issue is obviously a huge issue almost for all enterprises. You know, when someone comes up with a plug and play solution, that is the easy, and I like how Santiago calls it the sexy part. That is definitely the cool part of the project. That is the easy part. Let's talk data. This is where the biggest challenges that we see. If someone can solve that, that is kind of the real problem. And then lastly, I want to touch on something that we also see at Rolls-Royce, which is the regulatory aspect. So almost everything that we do within aerospace, so mission critical applications is the core capabilities that Rolls-Royce is working on. And almost everything we do have to pass at some point to a regulatory body that would approve the use or utilization of this technology. And Rolls-Royce have done a lot of work, which we can discuss perhaps later, in terms of how do we push the use of AI in these mission critical areas or application, for example, inspection and other areas. But that seems to be less of a concern for these plug and play, as in the interpretability, or is it explainable AI, or are you just using some algorithm that we don't really, we can't truly explain to a regulator? So that is an element that we usually struggle with here as well.
Yeah. Christian, is this something you're finding similar in scaling out across your organization?
Oh yeah, absolutely. In fact, some of our customers do not allow remote access, so getting the data is becoming really problematic. You have to go physically to the site, and bridging that gap of having a ready model with data that you cannot generate, that is. One way of approaching it, this is what we're doing, is essentially creating a lab setting where we can simulate a small scale of the facility, and for us inducting packages. But then again, the problem is the type of packages. We can't guess what would happen. There's so many sizes, shapes, materials, and different weights, and yada yada. And finally, one thing that not many people would advertise, usually you design your machine for a specific requirement. Let's say it has to induct so many packages an hour. They cannot be bigger than this size. They cannot be heavier than this size. Well, often what we see is that's not true. Packages are way out of spec. They're a lot heavier. So computer vision becomes important, to recognize that, and also to create a strategy to mitigate that problem, because we cannot just stop and say, oh yeah, we cannot do it, and we halt the entire facility. So for industrial automation, this is a big issue, where humans are very agile, and they can handle these exceptions. But if you design a system for a specific purpose, that becomes a pain point.
Yeah. And I want to latch on to something that Jacob said in his comments, which was it seems, easy is the wrong word, but it's less difficult to be successful in a proof of concept in an isolated environment, right? Taking it beyond that, much more difficult, clearly, particularly into really large enterprises when you think about Volkswagen Group, right? Or Rolls-Royce. And so I want to talk about, for those in attendance who have that project right now, right? And they've got a lot of passion for trying to scale beyond this POC. What are some of the things you're thinking about, both merchandising internally, right? Because you have to kind of sell this project throughout the organization, and then getting maybe other business units or employees involved. How are you thinking about trying to scale that beyond POC? What are maybe there's some technical steps, but there's also some political steps. I'd love to hear your thoughts on some of that.
Jacob, do you want to go first, or?
Yeah, well, convincing stakeholders is, at least in production for us, quite easy, because once you tell them you have a good business case, then they're probably on board, because the cost pressure is really tremendous within Volkswagen. So as long as you can tell someone you can save money with your application, then you probably have all the support. Still, people on the local level are usually quite pessimistic that it will work out, and of course there's always some skepticism towards AI, because there's a lot of misconception about AI. Still, I find once you can make it tangible for the workers in the plant, then usually they accept it quite fastly. And it's more on management level that you need to convince people that you can handle the complexity, and that you know what the requirements are that I mentioned, like 100% reliability and backup concepts and stuff like that. So once you convince the other side that you have that in mind, then it's usually a good situation to start implementing.
Yeah. Absolutely. First of all, agree on the easy selling of this to stakeholder. 3 points that comes to mind when we're discussing how do we move from a POC to a production system. First is the concept of a product owner, which is a role that is not exactly new. There has been an article 4 or 5 years ago, if I remember, from McKinsey company, about how do you simply utilize that role. Like the concept of someone who has extreme ownership of this product and seeing all its aspects, not just the data, not just the development of the code, not just the infrastructure or the stakeholder management, literally the whole thing, kind of I define it as a mini CEO. So think of yourself as a product owner, as a mini CEO trying to make it in this large enterprise. Having that role has been absolutely essential for us at Rolls-Royce in terms of the success or seeing more projects making it all the way to production as opposed to dying in the POC stage. So that is one thing. Another thing is the waterfall versus agile. So there is lots, as in we are perfect at generating good ideas that has billions of pounds or millions of pounds worth of potential in terms of saving for the organizations. Now, waterfall is where things go horribly wrong. As in, if you say, all right, I will deliver the value 5 years from now, I need 100 million pounds, I'm going to deliver £1 billion. That just simply, as far from a personal experience, that simply did not work. Agile, keep it kind of small, simple, stupid, if I may say that, as in just keep to the minimum, release the value sort of in an iterative way, and build your way up until you actually get more and more sponsorship and kind of a bigger project. So that has also worked really well for us here in the company. And then lastly, we came up with a system that sort of allows us to repeatedly move from POC into production through something we call a value delivery office. And the idea behind it is that we assign value to data. So something called DVP, which is the digital or data value premium. So data is an asset, and I hope everyone agrees on that. And it has value, which usually goes ignored in AI projects. So the fact is, as Santiago and everyone said, there is very little data to start with. The fact that most projects end up spending a year just creating the data, that has a lot of value for the organization. That usually goes ignored in the financial books, because did you actually save money? No, therefore, you haven't delivered anything. But we have delivered a lot of goodness. This data is going to be utilized in a lot of projects, and assigning a number, a value, a dollar sign next to your data is a good way that we found kind of to help gain more momentum and more support for your project within large organizations.
I really like that approach. But one thing that we usually find is that analyzing and coming up with the role of a solution at the time of deployment is critical. So usually we think about AI as, okay, so we're going to get this system here and we're going to replace this many people, or we're going to, be able to do something that we weren't able to do before. And unfortunately, getting to that stage might be completely out of, you might not get there in a reasonable amount of time. So we found a lot of success trying to think about AI as an iterative step where we're going to, instead of thinking, okay, so this system is going to replace people and it's going to take over this process, we try to come up with a way for the system to help the existing process. So if you have 10 people doing something, how can we make those 10 people be more efficient? How can we cut 1 second of time? How can we build these in a little bit cheaper? So thinking about how that system will step by step take over instead of in a full, instead of doing, completely getting rid of the current process, trying to augment your people is sort of like an approach that we've seen a lot of success with.
Yeah. So I'm hearing a couple of things. I'm hearing, the business case is always going to speak loudest, right? If there's money to be saved, if there's a really strong business case, that tends to get a lot less friction. I think the positions, the people you've got in place, right, at this product owner job, I couldn't agree more, right? Someone really has to own the success of this. And then taking small chunks, small bites, if you will, as you move along incrementally. Christian, are you finding all of those things to be truths as well? Or anything you'd like to add to that?
I can't agree more. And I just want to add something from the R&D perspective. Coming from a mindset of creating something that, we listen to our customer, they have a need, they want higher capacity, etc. They want a new device that doesn't exist. So we create this, let's say, robot simulator. It takes a lot of iterations, right? And you have to be ready to spend the time and resources. And when it's time to scale, you can't just take what you just built because it may not be optimal for production. So you have to coordinate with other stakeholders to design for production. It has to have a product owner, like we use modified stage gate. You have to create processes for handover, so it's actually deployable at scale. I cannot have my team spread out in 80 different cities deploying because I just don't have 80 people. Even if I did, it wouldn't be a good use of resources. And finally, one thing that's overlooked is what happens when you deploy the device. What happens when it breaks? How do you handle that? If it's one device, sure, we can all jump as a team and put all the efforts. But when you have 100 devices, that's not just doable. So you have to, even though when you have one device that's not required, you have to think with that mindset that when you scale, you want to reduce the number of occurrences of any sort of failure. So you can manage the scale, because producing is one thing, managing it and further improving it's another. So that's what we're seeing, and I think that's the key to success. That's what's going to make or break the product. And one more thing I want to add in, at MHS we approach things always from project first. So it comes from a need from a customer, and they're willing to pay. So they say, okay, we need this. Okay, we'll make it. We'll create it for you. We'll deploy it, etc. And that's a one-off, right? But maybe 10 off or whatever, 100 off. It's not the scale of Volkswagen, for example, or Rolls-Royce, but it's much larger projects. But one thing that we try to extract is what is the one common denominator, and that becomes a product. Then very easily then becomes a project owner and a project and another PO, and that's how we grow. Where I've seen the opposite with small startups that build something in hopes that a customer would want it, which is very hard. And
Yeah, I think Santiago would agree. So thank you for that, Christian. I think Santiago would agree. We see the same thing, right? What's the common denominator amongst needs with client prospects and partners, and then how do we build that into our product roadmap? So one of the things you mentioned was this idea of devices, and I'd like to just pivot a little bit. And I think we can't talk about industrial solutions to a certain extent without talking about advanced robotics and camera systems. I'd love to get a feel for how each of you are maybe approaching advanced robotic platforms and camera systems, different capture device platforms, where you might be in evaluating those, and then any particular use cases around that you care to share. I'd love to understand more about that space. So maybe Mo, we can start with you on this one.
Sure, yeah, absolutely. And you're absolutely right. So obviously of great interest to us here at Rolls-Royce, the advancement in robotic systems. So two particular use cases come to mind. So the first one is, I'd say, perhaps the best use case I could think of for installing a robotic platform in any way is the standardization of capturing data. As basically everyone was talking about, we get a lot of project requests. The question is, do you have the data? And obviously, after you pass through all the other questions, do you have the data? Yes. Start looking at the data. It simply is not usable for a machine. And I'm sort of hesitant to say this, but there's a story I heard a couple of times. I actually don't have a reference on it, but the story goes as in back in the 90s when everyone was looking at computer vision was kind of emerging as a promising field. The one of the use cases, like the one that studies the most, was about detecting breast cancer. And there has been a number of big tech giants trying to get into that space. And the one that cracked was actually a small startup. And the way they've done it is basically they train the technician, the technicians that take they capture the data, to standardize how to capture the data. And as we all know, if you have better, kind of clean, annotated data set, put any algorithms there, and you get to the 99%. To get to 99.1, you need like a state of the art. As in, data is everything in this space. So standardizing the capture of data, robotic platform is an excellent platform to do so. You kind of remove all the human errors and the elements around sort of how you shouldn't be capturing data. So that is one thing. And on that note, the application that we've used it for was around inspecting of damaged components. So as we receive, engines flying all across the globe, thousands of them, they come for our MRO shops, the maintenance repair overall. We take certain components out, and then we inspect them. And to inspect them, you could obviously, you start utilizing computer vision. And the issue that we faced at that time, it's a huge opportunity, was how do we go about standardizing the data capture? And this is where robotic platform were introduced in Singapore to start the process. We are currently collecting a large, massive data set, just collecting data at this stage. No training, no sentencing, as in nothing on the analytical side, just data collection. And hopefully once we have a large enough data set, we will be start to explore the computer vision space. Sorry, that was a long answer.
No, thank you. That was a great answer. I think it's exactly what we're looking for and what people are interested in that. And so thank you so much. Anyone else want to jump in here? Feel free. Santiago, I know you've got, we've worked with some robotic platforms, and that's where we spend a lot of our time. If you've got anything there.
I completely agree with Mo. Standardizing the data is a huge plus to ensure good results at the end, right? We work a lot with moving platforms. So yes, we are capturing using the same devices. So from that point of view, it's standard. The challenges that we're facing is when that platform moves and you cannot, getting a good shot is not always a certain thing, right? So imagine a platform that is not stable, but you still need to capture images. So we have to do a lot of work just to account for that, movement that happens in a moving platform. So anyway, it's very, very challenging. So yeah, it's interesting. It's a lot of work just to standardize those images. Yeah.
Jacob, Christian, anything in the robotics space that's particularly interesting to you right now, or that you're in the midst of?
Yeah, I have one. we're going from the other side, basically. Rather than using the robot to generate the data, we use the data to tell the robot what to do. And most of the time, you see robotic application as basically use case of repetitive operation, where the way we are using it at MHS is essentially every pick and every place is different, and it's entirely driven by computer vision and AI. And the sensor is a key part, but really the AI is, I hate to say that, but it's the brain. I know it's being used a lot, but that's regardless. So because of that reason, sensors are sometimes not able to give you enough accuracy. And even though you did your processing correctly, segmented out the image correctly, you still don't get the correct pick location, for example. So you have to take another step to enhance the robot motion to ensure that essentially you increase your pick accuracy. So that's something that is not so compliance, for example, right? So end effector compliance for robot, that is area that not many people talk about. And if you over-engineer, then maybe you lose range of height of motion of the robot, or weight capacity, or so there's no golden solution essentially. So that's always tricky.
Yeah, for us, to be honest, we didn't work on much yet on the robotics computer vision combination, because we figured out that there's so many use cases you can do without robotic integration. And since that's getting super complex and expensive very quickly,
yeah, fair enough.
We are at the moment focusing on things without robotics.
Yeah. Well, that's a good pivot point. And just looking at the time, I want to get one last question in. And because this is about innovation in this space, I'd love to just get a feel for what each of you are excited about, what innovations, you get the hair standing up on your arms when it comes to your particular business. Maybe Christian, we can start with you. If there's anything that, of course, related to ML and CV, anything that's got you particularly excited. It could be a use case, or it could be a technology or a model that you're learning about or testing.
Yeah, sure. One specific case is data annotation. This is a big pain point. We generate roughly per single robot, we generate about 20,000 images a day or instances. So annotating that is if you do it traditionally and you go one at a time and you have to segment out each image, it'll be not feasible, especially if you have 100 robots. And also the size of that data, it's in terabytes. So internally, we looked at different vendors, and we decided to put together a hybrid annotation platform that allows us to use ML, assisted labeling. So essentially, pre-train a model, gives us some hypothesis, and then 99% of the time, rather 90% of the time, the annotator is doing Q&A. So that can speed up basically 1,000 times, our annotation. One thing that we are hitting limits on what the current models are supporting. Just feeding more models does not, more data to the model doesn't improve our accuracy. So I'm excited with what's happening in CVPR right now. There's a lot of interesting networks that are being released, and can't wait to try it. Yeah, so I think from operational standpoint, tied to all that is the data pipeline.
Yeah,
so it's not being talked too much internally. A lot of companies have their own data scientists, and
Sure.
they'll spend a lot of time moving data, preparing basically for a test, analyzing these tests, and so on. There's some really cool tools that are now available to automate that entire process, and auto scale and so on. So I think that's that's where I think things are moving.
Sure. Yeah. Very, very functional, but also just unlocks, I think, success to Mo's point at the top of the conversation, right? I'll go again the same direction I did to start. Santiago, what's got you excited?
Yeah. So a couple of things. So number one, just to piggyback on Christian, the tools that are coming out that we can use right now that are going to take care of those pipelines, right? All the way from capturing the data to managing the data, transforming the data, analyzing that data to modeling, monitoring, etc. Like, for example, Vertex AI, Google just released. SageMaker is coming out with better tools, AWS SageMaker. So those tools are making our lives way easier than what it's been for decades. The second thing that I'm very, very excited about is the zero-shot models like OpenAI Clip, because of the amount of use cases that these models will unlock out of the box. Like, for example, OpenAI's Clip, you can use it to detect and to describe images, let's call it like that, describe images with zero training. And again, it might not be what you need for a full production version of your application, but it makes that POC phase, it unlocks a lot of use cases very rapidly. You can apply Clip with zero training, zero data scientists, and I'm very, very excited about that.
Yeah. I can attest to Santiago's excitement on that based on our Slack channels. Mo, what about you?
Excellent. Yeah, no, definitely agreeing with Christian Santiago. So the data annotation and the pre-trained models are definitely exciting, but both of these assumes you have data to start with to annotate or to train. Where I'm also equally excited is on the synthetic data generation front. So in fact, again, CVPR, there has been lots of use for GAN to generate massive amounts of data with a click of a button. Just simply specify the criteria of what you, as long as you obviously can train it, then you can generate almost infinite amounts of data that you could use to train the pre-trained models and then fine-tune them on real data. So synthetic data generation is the one that is currently exciting me the most.
Awesome. Thank you for sharing.
Yeah, that's a good one for sure.
And Jacob.
Yeah, I agree with Mo. That's also something we are working on. On top of that, probably a straightforward one. We are currently connecting all our plans to the cloud. That's coming back to the data topic. It's just such a tremendous help because that's for the first time it makes it really simple just to gather all data from each plant. And that helps us really a lot to share models and share data. That's a big one. And the second one that I really want to work on in the next 12 months is unsupervised approaches, because I'm a bit sick of supervised learning in computer vision. There's so many times where customers cannot tell you what are they looking for, what are the defects you want to detect. And that's something we want to play around in the next couple of months with unsupervised approaches to see if that works out in production context.
Yeah, that's great. I think the message I'm hearing loud and clear is we've got to get the fundamentals right, but before jumping into scaling any of these things. It's just the data fundamentals are so critical. And it seems like some of the innovations coming from all of you have to do with making sure that process is airtight. So thank you. We're going to move into some questions, just looking at the time. Want to make sure we can get some of these questions in. So I'm going to ask them. Thank you guys for submitting questions, all those in attendance. First question here is from Tonislav. What can we do when we have little labeled data? Can we leverage unlabeled data? So anyone want to take that one?
I can start. Definitely, you can. So look into active learning. It's a semi-supervised learning approach where you can use the little label data that you have to help you label the rest of your data. So we're not going to get into how to do it, but it's basically active learning. That's the name of the technique. And it's an iterative approach. You start with very little, you label a little bit more automatically, and then you go from there, making that data set more and more annotated as you go. So it is very used in real life productions. You can think about like an oil rig, and you want to determine whether there is oil here. And the only way to label your data is by, punching a hole in the ground and seeing whether there is oil there. And there is really no way to do that in real life. So you need to use these approaches.
Yes, thank you. Unless anyone's got anything to add, I'm getting nods that's good. I'll go to the next one here. This one is from Pawan, and it's similar in nature. And I think this actually is something that Christian was touching on earlier. How can we reduce the data annotation part if the data set is really huge, and how can we validate it? So broad question, but really, about, you were talking about annotation earlier. How do we reduce that or essentially find some efficiencies in annotation? We've got really large sets of data.
I want to add something here. One issue that we found is working with different annotators. That they will annotate differently, for example, the same 10 images. And it's very important to create guidelines and to follow those. And that scaling that on itself is a task.
Mm.
Yeah.
So finding reliable annotators is probably the key. But if you can't do that, then you have to have a good Q&A, right? So good quality control. And that could be done, different ways. You can have some sort of randomized process where you randomly pick certain images. Maybe you can do ML assisted, and you can maybe do every other one, so it's not random. You could do secondary Q&A, etc. So we also found good use of let's say do classification. As we do classification, we get the new batch data and we retrain with the new data. There are images that just don't fit. Just visually seeing those, why do we say that this is let's say a single package versus it's two packages? Was the data annotated correctly, right? So just I know dealing with millions of images is not practical, but if you have, let's say, 1%, maybe you can visually very quickly identify part of the data and then relabel that way. So that's part of the Q&A kind of check.
Yeah. Pawan, maybe Christian is someone you can reach out to after this, and you guys can connect and talk through some of those circumstances. I'm going to move to the next question here. I'm going to go from one that's relatively broad to one that's quite specific. And Ragith wants to know, while using deep learning, is there a preference for the library used, PyTorch or TensorFlow? So I don't know if this is a polarizing question amongst the community, but
it is. Yeah, we are. You can go ahead.
Well, actually, I was going to say we use both. We actually are happy to maintain models from both. I also want to add there's a library called FastAI, obviously not advertising for it, but it's built on top of PyTorch. It's quite a good library. I would highly recommend you also have a look at that one. But we use both, actually all three of them.
Excellent answer. Yeah. Non-controversial answer as well. I like it.
Yeah, you usually see PyTorch more used in the research part. It's gotten very popular. And TensorFlow is more enterprise focused, you can say. Internally we use both. Personally, I'm a TensorFlow person, but at our company we use both.
Yeah, from my perspective, most use cases I've seen didn't have that much of data science needs for digging super deep into it. So most of it was really super simple object detection, and then you can go with any of the standard TensorFlow pipelines, label a couple dozens of pictures, and they usually have a very good model. So for us, we work with both, but really that's not a key challenge.
Okay. Next question from Alexandre. How to prevent data leakage in real use cases? I think the question is about data leakage. I think, Santiago, you were alluding to this a little bit earlier. What would our approaches be there if anyone wants to take that?
Well, it really depends on what you call it. I've seen the term data leak used in multiple contexts. I'm going to address one of them, and if anyone else has a different approach, just go ahead. So data leak is when you sort of like leak the knowledge of a portion of your data set into the model itself. So basically you overfit to the training data. Let's say because you are training your model, seeing the results, and sort of like modifying that model over and over based on the test results that you're getting from that model. So there's sort of like the knowledge is going to leak into the model. And what's going to happen is that your model is going to perform very, very well in your test case. And when you go to production, that model, it's going to be a huge gap between the performance in production and the performance on your test set. And the way you solve that is good discipline. So number one is awareness that that's happening. And number two is good discipline on how you use the test, the data that you use to test that model and what you do with those results. That would be on my case. I don't know if anyone else has a different definition for data leak.
I want to second the awareness part. I feel that is definitely, as in data scientists tend to have the reputation of being a bit of a cowboy when it comes to dealing with the data. So definitely better awareness, which is something that we constantly have to stay on top of, because as we bring more and more data scientists, they don't necessarily know the best practices of software development or data ops. And yeah, but I feel it's more of a cybersecurity question, and this is perhaps a different arena. But we work closely with our cybersecurity team and others to make sure that this never happens.
Thank you, guys. I've got one last question, and then we'll wrap it up here, being respectful of everyone's time. Thanks for the insightful session. In an industrial setting, volume of data is generally not a challenge. However, finding the right data to annotate and build high-quality models is the real challenge. How do you address this? Can you share a few best practices? Anyone want to start with that one? It's I think it's a big question. Clearly, it's a challenge. Essentially asking how do you build around the right model. But anyone want to jump on that one?
I have a kind of a good story about this one. So as we run this conveyor belt system, so away from the robot and the simulation and using cameras, traditional sensors are just is the robot running? I mean, is the conveyor belt running? Is there any sort of actual vibration? So you could approach this from how can I do preventive maintenance? Because if that fails, the entire facility shuts down. So you have to, but you cannot have spares because they're very expensive, and it just doesn't make sense. You want to have it pretty much just before it breaks. So you need to know when it breaks. And collecting data at a high frequency, even if it's just vibration, on multiple conveyor belts, let's say 1,000 conveyor belts, can add up very quickly. Then transferring that data to a central database in a facility that's made of concrete and steel is also a challenge, especially if you're not allowed to use internet, local network that they have. So that's the collection part. The analysis, generally, doing fault detection and preventive maintenance is done. Establish a threshold when you recognize certain failure. But that can vary across sites, because there could be the entire platform is vibrating or something else. Basically, a threshold is no longer valid. So establishing what is normal and what does it mean to be abnormal, when you do the detection. So you can leverage some techniques. The example I'm giving, actually, majority of the time, 99.99 is the type of, there's no failure, and there's only very, very small failure points. So you can generate this in the lab and somehow translate that model and be okay with false positives, as long as you can maintain production. So that's currently how it's done in a lot of companies. You allow that increased amount of false positives just so you can continue to run, because there's just no data. But he's right, like annotating good data is hard, especially for the application.
Yeah. Anyone else have any thoughts on kind of cutting through the volume of what possibly could be annotated to focus on the right data for a particular model?
No, I think Christian covered it well. This is one of the biggest challenges. Companies like Lending AI, which is Andrew Ng, somebody mentioned Andrew before, is trying to tackle this challenge. as well with what Christian mentioned before, with having multiple annotators annotating the data differently. So they are trying to tackle that with their startup. This is one of the biggest challenges. How do you select the right data, and how do you make sure that data is properly annotated? So yeah.
Wonderful. Well, that was the last question I've got, and we're just a little bit over time. So thank you guys for sticking with us. Great discussion, and we appreciate the time from all of our panelists and, of course, all of our audience who decided to spend the last 45 minutes with us. Hope you enjoy the rest of your time at the CV Festival. And for us here, thank you.
Thank you very much.
Thank you.
Yeah. Bye, guys.
Bye-bye.